So we are going to start today permutation and combination. Basically, it's a chapter in grade 11, and it's considered to be one of the very difficult chapters. Okay, give me 1 second. Yeah. So in this chapter, we will try to complete and understand first of all how this arrangement works and how we are able to select a few things out of certain things, and then also, if possible, not in this session of course, but in the next session we will try to introduce probability with permutation and combination, and it is a very useful technique to solve a lot of probability based questions, and this is helpful in grade 12. So whatever you are studying now is a general life situation, but again it will be going to be used for grade 11th and grade 12th maths. Okay. Before I start, I just wanted to let all of you know that if you are not on Discord still, please do remember to join that. Okay, we are introducing a lot of characters here, and we are also discussing a lot of things in the daily challenges. Okay, so if you are not still here, then please do be there. Please be there. It will be very helpful for you to discuss after the session all the problems related to each and every session. So maybe it Ikigai, maybe it is Google Sheet, or there are some daily challenges and a Super Saturday. Okay, now let us begin with a very basic thing. And this is going to be like more of you answering a lot of questions. The solution steps are very small. Its the major use is going to be your logical ability and logical thinking. Okay. So let's start with very basic thing. We are already doing this thing in the binary cases and also in the head-tail cases. So the question comes out that how many possible codes are there for this type of keypad lock? So you can only use the digit 0 and 1, and you have to fill 3 places. There is no limitation on what it will be. Let us try to solve it using the very basic approach we were taught about it. Consider it like a head and tail, a single coin tossed 3 times. Okay, and this is how you do it. So let's say these 3 places be A, B, and C. So let the 3 places be A, B, and C. Okay. Now you know that I can fill these places either by a 0 or by a 1. That's the only choices we have. So this 0, 0, 0, and I hope you remember that I have taught you one fastest way of doing it. Head, tail, head, tail, head, tail situation. So 4 head, 4 tails kind of situation, 2 heads, 2 tail kind of situation. Yes. So if you remember that, okay. Now, in that situation, what we can do in this is we can create all the different combinations that are possible with 0 and 1. Yes, you must have seen this in your suitcases. They come with 3-digit codes in general, correct? And you just select the codes. So consider that the situation is you can only select either 0 or 1 for the 3 places. These are all the different combinations that can be. Don't worry about, don't take it as a permutation combination word, just take it as a combination in general English word. Okay, why is this? Are you not all okay? Can anyone please type something there? I think my chart is paused or something. I want to understand whether it is going live or not. Okay, so we see there are total 8 cases, correct? So the total cases that we have is 8. Oh, it's fine. Thank you, Deepika. So remember that there are total 8 cases. Now this tells us that this clearly tells us that we can always write all the different combinations and we can always count the total number of combinations and we will get the answers. But what if we have a very easy way of doing it? And that should be taught to you, correct? So let us now understand the 8 combinations. Remember that if I say A, it can be filled by either a 0 or by a 1, correct? Same is the case for B. It can be filled by a 0 or by a 1. And same is the case for C. It can be filled by a 0 or by a 1. So basically there are 2 cases for A to be filled. There are two different ways for B to be filled, and similarly 2 different ways for C to be filled. Correct. Now this implies that the total ways will be 2 times 2 times 2 and is equal to 8. This is also called the fundamental theorem here. Okay. We will talk about it later, but not now. But remember that in this way we could have solved this problem in a much faster way, much faster way. Okay, so let us now take up the next one. This is what I was talking about, the fundamental principle. So it's the fundamental principle of counting, where if certain thing can be filled, or any action can be performed in m ways and n ways, then the combined action, okay, the two actions, combined actions can be performed in the multiplication of those ways. Okay, this is what you call the fundamental principle of counting, or the rule of product, whatever you call it. Okay, and this is the rule we are going to rigorously use from now on, up till until not up till until we complete the permutation. Okay, so let's begin with it. Let's begin with our problem one. Okay, by the way, the approach is so easy. The channel name is the problem solver. So I will teach you through problems only. Not much theory here, more problem. And every theory will be coming out from the problem itself. So try to understand the problem very carefully. The theories are going to be derived from those problem only. Okay, let's begin. So a certain type of keyword, a certain type of keypad lock has 4 number keys. We can see that. This allows user to enter at 3-digit code. Okay. Now the possible codes can be like 203, 033. So remember that this is an easy question because 033 is allowed. If 033 is not allowed, it becomes a little difficult question. But for now, we are understanding, we are just going through very easy steps. So we will take up only simple cases. Okay. Now, let's understand how many possible codes are there for this question. So first of all, 0, 1, 2, 3. You know that the first place can be filled in how many ways? Think about it. The first place can be filled in 1, 2, 3, 4 ways. Correct? And same is the case for the second place. It can also be filled in the 4 different ways. And same is the case for the third case, or the third place. It can also be filled in 4 different ways. This actually, by using the fundamental principle of counting, we can now say that the total possible codes, or the total possible codes are how much? They are 4 times 4 times 4, which is equal to 64. You can go ahead and try doing it. You can go ahead and say, okay, sir, I fixed 1 0 and I can take a 0 0 0. I can take a 0 0 1, a 0 0 2, a 0 0 3. Okay, 1 0 0, 1 0 1, like that. And there are still 0 1 0 which I have left. So there are many codes that you can make, and 0 1 1. No one is stopping you. So because 0 3 3 is allowed, you understand this? So in this way there will be many codes, but why will we waste our time? So we will just do this fundamental principle of counting and we will get the answer. Hope you all got it. Camera is blocking the right side. Oh, is it? Thanks for it, beta. Okay, now if it is fine, I hope so. I brought it to the left side. Okay, so now in this way we can have all the different codes. Okay, now let us take the next one. Okay, the situation has changed a little and we will now try to understand this situation. Okay, what would make this lock more secure? Remember that whatever you're going to understand is going from very fun, no permutation. I have not used it. Okay, so remember that I will be using it, but not now. So please be attentive when you are understanding this thing. Okay, making the codes 1 digit longer. That's the first case, and adding one more number key. Okay, how will you understand which is more secure? Can you tell me what do you mean by when I say more secure? When do you think a code can be more secure? What mathematically what it should imply? What do you think? A more secure code will be what? So let me see if I get some answer here. A more secure code. So let's say you have this 4-digit pin for ATM, more combination of numbers. Correct, Deepika. So if you have more combination of numbers, then it will be a more secure code. Now, it is a very basic thing that is used in your ATM also. In ATM pins, have you seen they use 4 digits? And I hope now they are using 6 digits to make it even more secure for someone to crack. Let us see what difference, what it makes. Okay. Now remember that you are not allowed to use all the digits like 0 to 9, you are only allowed to use the 4 digits 0, 1, 2, 3. Let's make the case for A. For A, you know that all the 4 places, they can be filled in 4 different ways, because you have 0, 1, 2, 3. There are 4 numbers, there are 4 places, and every number can be repeated. There is no restriction as of now. So the total number of ways T in case of A is 4 times 4 times 4 times 4, which is how much? Someone can tell me. It is just 64 times 4. You can calculate. Okay. In the case of B, what happens now is I get a situation where I'm using 3 places only, but I have increased 1 digit. So instead of now 4 digits, we have the liberty of using 5 digits. Okay. Now this implies that each place can be filled in 5 different ways. How many different ways? 5 different ways. Now this implies that 5 times 5 times 5 will be the total possible ways in case, or the total codes in case of B. Okay. So now understand one thing, okay? 5 times 5 times 5 is 125. Okay. Now here is the clue. Okay, thank you, Deepika. So this is 256. So increasing one place resulted in more codes compared to increasing one digit. Hey, this will not always be the case. Now up till, what's this word coming out? I don't know where I read it. 666. If I increased one more digit, it would have given us 216. Correct. But the problem being, after, it is still even less than 256. It's okay. But once I increase the digits to 7, then this will become more secure. But for all intent and right now, 256 is more than 125, and therefore, which is more secure? Which is more secure? The code A is more secure. Correct? This is more secure. So I hope you have understood this part. This is a very important point. It also let us know that if I have a 4 place with even 4 digit, my code is more secure than 5 digits. Now it's just I'm waiting for you all. Can you all tell me if you have got your ATM card? Don't tell your pin, okay? Okay, just tell me, if I give you all the 0 to 9 digits, 0 to 9 you can all use all the digits, and you have this 4 liberty, what are the total possible codes? The total codes. Let me see if you can answer it. I'm waiting for it. Can you tell me, if you are using 0 to 9, which is allowed in your ATM, where you are allowed to put 0, 1, 2, 3, any digit, and you have 4 digits to be filled, 4 places to be filled, can you tell me what are the total number of codes? Deepika has given me an answer of 10,000. I think she's the only one who is answering me. So, and she is obviously the correct one also. Yes, from 0 to 9 there will be 10 digits, and this implies that we will have total of 10 places. So 10, 10, 10, 10. We have 10 choices for each place, so there will be 10 times 10 times 10 times 10, which is nothing but a 10,000. So there will be 10,000 codes. That's enormous. That's enormous. So someone, if he has to crack your ATM card, the pin of it, he needs 10,000 of it. But what, let's say what happens if you somehow he gets the first, when you are typing it and he sees it, and now he knows this value is fixed, let's say it is 7. What happens now? How many codes does he has to try now? Let me see if you can understand this. Okay. I know that Deepika will be answering this one also. It's a very easy one now. Absolutely correct. It's just 1000, because now the good Mansi is also there now. Okay, so now you see that all these numbers are locked up. This is 10, 10, 10, but one, this is there. So 1000 total variations are possible. Can you see, just fixing one digit? Understand, this is a very important point. Just fixing one digit reduced it to such lesser number, 10,000 to 1,000. So can you understand? 10,000, 1,000, 9,000. Once he knows one digit, he has reduced all the choices by 9,000. He doesn't have to try the 9,000 left choices. So this is why it is such a very crucial case that you even don't disclose any of the digit when you are in your ATM. That's a learning here. Okay, let's move to the next one. Problem 3. Now this could be answered very quickly. I hope you have all have understood the process now. You have got the gist of it. I'm not explaining anything. I'm just waiting for 1 minute and I want to see the answer. Remember that in this case, each number can only be used once. That's the point here. Let me see if you can answer this perfectly. Only once. You are not allowed to use it repeatedly. So you cannot, if you use 0, this is locked. Let me see what will be the answer. 24. Okay. So, oh, sorry, there are 3 places only to be filled. And that's very correct. Since when I'm putting the first place, now some people will think why it is 24. Understand, okay? Suppose the first place you are able to fill in how many ways? Total there are 4 digits to be filled, and no one has said that your number cannot begin with a 0. It's a code, so it is okay. So you say that this can be filled in 4 ways. But the moment you fill one digit here, and it can be any digit, we do not care about it. The moment you fill it any digit, you are left with only 3 digits now. Only 3 digits now. So in this situation, you can only fill the next place only by 3 digits. You can't use the 4th digit because it is locked, and it can be any digit. There is no restriction on it, okay? And it doesn't matter actually. Now, once you have filled the another digit, now you are left with only 2 digits to be filled, and therefore you are left with 2 choices. Now, this will give us the answer as 24, which Deepika also correctly said. What if there was one extra place? Understand, this is why I want to make you understand what happens actually. If I even had one extra place, it wouldn't have added any benefit to our situation. Compare this with the last situation. Having one extra place, gave us 9,000 extra codes. When repetition was allowed, having one extra place gave you 9,000 extra codes. But removing the repetition and putting restriction on it that you cannot use any digit twice or the next time, you are now being pushed with no change. So in this situation, let us understand this in this situation, okay? If there are 4 digits and all the places are allowed to be filled repeatedly by any digit, it doesn't matter. There will be total 216 codes. So if I reduced one place here, there will be at least it's still 64 codes. Now, but in this case, adding one, so now you see the drastic jump. When the repetition is allowed, adding one place, one extra place. Oh, sorry. I'm so sorry. So adding one place gave you how many? 256 total, correct? Now you notice what happens. Now you notice what happens. This extra creates and helps you when repetition is allowed, but when repetition is not allowed, extra digit gives you nothing, because even if you multiply this, it's 24. Even if you multiply this total, it is 24. So in general, that's why repetition is allowed in ATM cards, because it gives us more benefit of having this extra place also. Okay, hope you are comparing the two situations and you're understanding the practical implication. Now remember what happened just now, and let us bring the factorial notation into picture. This is a mathematical term used a lot. When you write something like 4 3 2 1, basically when you write like 4 times 3 times 2 times 1, or you can say that 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now this in mathematics is used so much that mathematics came up with a symbol for this process, and that symbol was like an exclamation mark, and this is what we call the factorial notation. So when this symbol is with something like 4 factorial, it implies it is 4 times 3 times 2 times 1. It is read as 4 factorial. Okay, 4 factorial. Now this is 4 times 3 times 2 times 1. Okay, now if it is with 8 factorial, then it is the same thing like this. So this is 8 factorial. So if putting a symbol like n factorial will mean that it is n times n minus 1 times n minus 2 times n minus 3 and so on till what? Till what? Till 1. Till we get a 1. Okay. So this is how n factorial is expanded in general. I hope you all have understood this part. It will be now used for writing the final answers. So rather than writing this long answers that we were writing continuously, we will now cut it short, save our time, and write using factorial notation. Okay. So let's begin with the factorial notation now. Let's take up the again one question. So now we are going to write the same question using factorial notation. I hope it is readable enough. Let me just quickly make it a little big so that you all can read it. Okay. Now, let me wait for it. I want to see what the final answer comes up. So that will be very helpful actually. So let's see. Can you tell me the final answer in terms of factorial now? I don't want the final in the expanded form because this is not we are learning now. The learning concept has changed. Okay, I'm just waiting for it. Okay, Deepika came up with the answer as 9 factorial. Mansi also says the same 9 factorial. Okay, let's see. There are 9 number keys that allows user to enter a 4-digit code, and a number is used only once in a code. Now, let's understand this, okay? If I can place this first one in 9 different ways, of course, yes. I can place the next one because now I have used one of the digit. And it is not like I'm using one. Please do understand this is a very basic confusion with all the kids. Okay, they are always thinking that I'm putting a one value here. No, I'm not putting one. I'm saying one digit, and it can be any. It can be a 5 also. It doesn't matter. But it can be filled in 9 different ways. The second place can be filled in 8 different ways. The third place can be filled in 7 different ways, and the last place can be filled in 6 different ways. Actually, it is just 9, 8, 7, 6. The problem is, I think you both missed it. When you say 9 factorial, you mean that it is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But this is not 9 factorial. This is not 9 factorial. This is stopped at 6. It should reach to 1. But I can write it as 9 factorial. I know this is my total answer. This is the total answer. I can say this is 9 times 8 times 7 times 6, and I increase the value for 5 times 4 times 3 times 2, and I also increase the same here. Math is still the same. The final value hasn't changed. I have just added a 5 into 4 into so on till 1, and a 5 into 4 into so on and 1 in the numerator and denominator. Cool. Now, notice the numerator now though becomes a 9 factorial, and the denominator now becomes a 5 factorial. So the total possible cases or the codes in this case are 9 factorial by 5 factorial. Please do understand what you have just now understood is going to be used in permutation. Okay, this is the journey from factorial notation towards permutation. This is how we are going to move. Okay, so this is 9 factorial by 5 factorial. Okay, is it clear? Is the confusion clear? This is not 9 factorial because it would have been till 1 multiplication. It is not multiplying till 1. Okay, and we are going to use it in the next part. Superb. Let's take up the next part. Great. Now can you all simplify and tell me which is the larger value here? Let me just make it a little bit for you. Okay, Is it 9 factorial by 7 factorial, or is it 7 factorial by 4 factorial? I can teach you one very basic thing, and that will help you a lot. Okay, so before you make this jump, understand one very important point. There is no need, listen carefully, okay? There is no need to expand the denominator and the numerator both. Never. There is no need. There's a trick to do that. I know that I will write this as 9 times 8 times 7 times 6 times and so on. I can stop at any point and I put a factorial there. I know it has to go till end. Why should I write till end? I will just go and stop it at 7 factorial. The reason I did it because now I don't need to expand it. Yeah, it's like a very easy way of doing it. Now 7 times 6 times 5. I know I can go like 4, 3, 2, 1, but why should I go 4, 3, 2, 1? It's a packed form of 4 factorial. So now you get a 4 factorial and cancel. Now you get 7 6 out. So 5 6 is 30, 210. So now we can easily see that 7 factorial by 4 factorial, absolutely correct, Deepika. This is bigger. Clear? I hope so. It is clear. You already got it. That's very good. Let's move to the next one. Now this is what I was talking about. You can always, this is why I wanted you to understand that from the problem. I told you, first you have to solve the problem, use it, and then you get this, and then you get the theory out of it. So here is the theory. N factorial can always be written as n times n minus 1 factorial. Now this is a very, very useful relation. Please learn it, and it will help you to solve very big problems in very easy manner. You can always say that I can write like n into n minus 1. Consider this example that I can write 9 factorial as 9 times 8 times 7 times and so on. Why should I write this all? I can just say it is 8 factorial. Compare the value of n. If n is 9, then it is 8 factorial here. And you can always stop at any point. You can still go like 9 times 8 times 7 factorial. That's not wrong. That's the extension of the same formula. Okay, let's move to one of the question now. Use this definition. Oh, I have to bring this thing first. Okay, now I should not have shown you that. What do you think will be 0 factorial will be? What do you think 0 factorial will be? What do you say? What will you think? What's the answer? If you have seen the slide, of course, that doesn't make any sense, but still there should be something. What 0 factorial can be? 0? It's 0. Deepika comes with the answer 0. Let's see using this formula. There is no 0 factorial, okay? Like that, okay? Let's now use this. Let's now use this recursive relation and now try to bring it something better. Okay, tell me what is 2 factorial. Let's put the formula here, okay? All of you, please understand this. This is 2 times 2 minus 1 factorial. You all agreed that the formula is correct and it is true without any kind of conditional. This is not like P by Q where Q cannot be 0. This is not a formula like that. This is a very general formula applicable for all this positive numbers, including 0. So now you see, this is what? 2 times 2 minus 1. So 1 factorial. Now I hope 1 factorial you all understand is just 1. This is like very easy. So 2 factorial is 2. Yeah, true. Works. Let's write 1 factorial. Now you know that 1 factorial will be 1 times 1 minus 1 factorial. Okay, so what is 1 factorial? You know 1 factorial is 1. You all understand, and this is a true thing. 1 factorial is 1. Yes, it is. Then only 2 factorial will be 2. Correct. So this is 1. Okay, so this is 1. This is 1. And this is 0 factorial. So what is 0 factorial now? Let's make the subject 0 factorial. It is 1 divided by 1. What is 1 divided by 1? It is 1. It is defined and it is not 0, but it is 1. Okay. Now why is it so? Why does 0 factorial is 1? Let me make you understand through a real life example. Okay. Why do you say 0 factorial is 1? Now when you see and write 2 factorial, you say that you have got two numbers, let's say 5 and 6. And you, how many ways you can fill this thing? Okay, I say that this can be filled in 2 ways, but if certain digit has been used, either a 5 or a 6, then I cannot use any other digit, so it is 1. So we get our answer 2. Works. I understand it is correct. Now, let us say that you have got just one digit, 5. Okay, and you have got just one place to fill. Okay, and there is no repetition, so this place can only be filled in one way. That's correct. So this is one way. Now you have got nothing, and you have got nothing to be filled. This is more like I'm saying, what is the way of not selecting anything? There is still one way, correct? If someone has asked me, what is this way of not selecting anything? Not selecting anything. So you are not selecting anything. That is still at least one. Empty set is still one because it is empty. Otherwise, how will you define it? Can you understand this point? I am saying, what is the ways of not arranging anything? That's just one way, not doing it. So this is why you say the answer is 1. That's why 0 factorial is 1. When you are saying that you are not arranging anything, it is still single way of doing it. You understand what is mean? When you say 0 factorial, you mean that nothing is being selected, nothing is being arranged. If nothing is being arranged, that has to be still one way of doing it, of not doing it. That's correct. Hope you all understood that. I'm just continuously speaking. There's a delay. I know that. Okay. So use the same property that 0 factorial is 1. Not doing anything is also one way of not doing it. Okay. This is why you say 0 factorial is 1. Okay. Now all of you now try to solve this one. Remember, there is a very crucial, if you are not able to see it, there is a factorial sign after the brackets also. I don't need the answer in the expanded form. I just need the answer in the factorial form, and it will work. So quickly tell me what is the answer here. Remembering that 0 factorial is 1. Okay. I'll give you like one more minute. It's fine. I want to understand this. Okay. Someone, Deepika gave the answer as 25 factorial. Let's see. 0 factorial is 1. 4 factorial is 4 times 3 times 2 times 1. Okay. And this is 1, and this whole bracket is 1 factorial. So this is 1 plus 4, 3 is 12, 24. So it is 25 factorial. That's correct. That will be the answer. Very easy. Okay. Let's quickly solve the next expression. Apply all the things that you have understood. This is the last problem, I guess, so for factorial. So I'll apply all the things that you have gone through. Okay. So use everything now. Let's say this is 100 factorial. If you are using your way, I'm just, there's a lot of delays. If you're doing it on your own, very good. Very good, Deepika. Very good. So now you can all cancel this term, this term, this term, and this can be just such a short, smooth answer. Yes? I hope you all got it. I hope, Mansi, you also got it. Oh, it's going on. It's not stopping. Okay. Lot of questions on factorial. Great. 100 factorial times 100 factorial is bigger, or 99 factorial times 101 is bigger? Let's see. Which one do you answer it? So the first is 100 factorial times 100 factorial. Now you know that it is 100 times 99 factorial. This is 100 factorial. Okay, let's keep like this. Let's see the case for the next one. This is 99 factorial times 101 factorial. So this is 99 factorial times 100 times, oh I'm sorry, times 101 times 100 factorial. So this is 99 factorial, this is 100 factorial, oh this is 101, and oh this is 100. Yes. So this clearly tells us, correct, both of you are correct, good, very good, okay, very good. So both of you understand that this will be bigger because it has got 101, not 100 multiplying. Yes. I hope now you must be like very comfortable with factorials and all, like super comfortable, correct? So you have literally understood how this algebra for factorial works. Okay, let's try for this one. This is different, okay? This is 100 factorial minus 99 factorial. And this will give us 100 times 99 factorial minus 99 factorial. Now in this case, we can take a 99 factorial common and we will have 100 minus 1. This is nothing but 99. So this is 99. Okay, let's solve the next one. The next one says it is 99 factorial minus 98 factorial. So this is 99 times 98 factorial minus 98 factorial. So this is 98 factorial common, 99 minus 1. I hope you have understood the answer so far. This is, I'm just writing for completion of the question, nothing else. It clearly tells us that there is, you can clearly see, I hope both of you can clearly see that in case of this, it's such a big number. Both the numbers are bigger. Even 99 is bigger than 98, and even 99 factorial is bigger than 98 factorial. So there is no way, yeah, there's no way that this can beat this one, and this is bigger this time. Yes, very good. Now all of you, now listen carefully. Okay, we have arrived at permutation. Now what does it mean? It means that we have used the factorial to count the number of ways. Now remember what happens when I say that there are digits 1 to 9. Listen carefully now, okay? Okay. Now if I say that there are 3 digits, that a number is of 3 digits, works out. Digits are allowed 1 to 9, so there are 9 digits, okay, and no repetition. So this can be filled in 9 ways, this can be filled in 8 ways, and this can be filled in 7 ways. We already made one error. Yes, remember, we thought it will be 9 factorial, but then we found out that no, this is not 9 factorial. This is 9 factorial by, can I know the answer now? 9 factorial by, yes Deepika, correct, it will be 6 factorial. No Mansi, not 7, not 7. If you take 7 Mansi, this 7 will get cancelled, correct? But we want to keep the 7. If you take 7 factorial, then this has to be packed into the factorial. Yes? So we want 9 into 8 into 7 to be saved. We want to vanish from 6. So we need to vanish the 6. Correct? That's why we need a 9 factorial by a 6 factorial, because we only want to eat the 6 factorial, which is coming in 9. Yes? In the 9 factorial. Okay. Now, if you all can guess the pattern, I will be more than happy. So I will give you one more hint. Tell me what if it was a 4-place thing? Same thing, all the rules remain the same, nothing I'm changing, okay? Can you tell me what will be the total number of codes that you can decide? I really want you to find that 9 factorial by 5 factorial. Okay, what if I now had 5 places to fill? Then what will be the code? Yes. Have you got a pattern here? Do you understand why it's like this? Can you create a pattern here? When you are increasing the number of places, notice you are decreasing the number of factorial. Actually, it's not like this. Actually, the constant is fixed. The total value is always at the top. Yes, if there are, let's say, n digits to be selected, you have a choice of n digits. So in this whole world, they have told you that you can use all the n digits. Now this can be any n digits. It can be using a, b, c, x, y, z, whatever. I don't care about it. I'm just saying there are n possible digits. We write the n factorial here, and if we have to make a code of, let's say, r places, how many places? R places. If suppose we have to make a code for r places, then this denominator should be what? Can you find the pattern? If you can find the formula for permutation. Actually, this is how it comes out to be. You're coming from a problem to a theory. I hope you understand this whole benefit of doing it. I'm still waiting if someone gives me the answer. Have you understood the pattern? Yes. Okay, let me see. Mansi has written n minus r. Okay, there is one small error, Mansi, though you have got it correct. Remember, okay, this is like the golden words for factorial. Never ever think that these two are same. No, because this means n minus r factorial, while this means first you subtract, then you take the factorial. Do you understand this part? I know that you meant the same thing, but I wanted you to understand that this should not be the confusion ever. Okay, I understand that you must have meant the same thing, that it is n minus r, and which is correct. Why so? Because you see, when you have 4 places, you are doing 9 minus 4 places. That is why you're getting a 5 factorial. When you have 3 places, you are doing actually a 9 minus 3 places, and that's why you're getting a 6 factorial. Now notice, when I increase the number of places to 5, you are doing a 9 minus 5. That's why you're getting a 4 factorial. And if this is true, we are always subtracting the number of places we need to fill. In pure mathematics, we say we are subtracting the number of places that needs to be arranged. Okay, and n is the total number of things that needs to be arranged. Okay, so total number of things given to you, it is n. So this is how you get and derive at it. So remember that this is what you call permutation. Selection of items. Okay, this is what you call permutation, and the order matter here. It's an ordered selection of items. You calculate all different types of orders, so the order matter here. So 001 is different from 010. Listen carefully. In permutation, 001 is a different value than a 010. They are not same. In combination, you will understand it is same. It doesn't matter at all for them. So this is like, I can have 3 books. Listen carefully, okay? Listen very carefully. I have got 3 books: physics, chemistry, and biology. Now I have been asked to arrange these books in my rack. Okay, so this is, I've got a rack, and I have to put these 3 books in it: physics, chemistry, and biology. Now in terms of permutation, I know that, listen carefully, I know that this place can be filled in 3 different ways, because I can either put a physics or a chemistry or a biology book. Once I put one book, that one book is gone. So the next book I need to put is either of a chemistry or a biology, or a physics or a biology, depending upon whatever I have put here. But I know that the number of the books has reduced by one amount. So the next place can be filled in either 2 different ways. And this comes to the final result, that the last place can be filled only in one way, because there is no way you can select now anything. That's the only thing you have to put. So the total ways are going to be 6. 3 times 2 times 1, you know it, because this is how fundamental principle of counting works. Correct? In terms of, listen carefully, you are now arranging 3 things in 3 places. You are now arranging 3 things in 3 places, which is also 3 factorial. So what it means, you are arranging n things in n places, because this time your r has become n. So therefore the final value is again n factorial only. Now this symbol is called npn. The p is used for permutation. Okay, I'll bring it. I'm just teaching you a lot of things. I'm trying to bring a lot of things later on. Okay, let us see if we can understand this. Okay, this is going to be a little bit lengthy question. So Please pay attention now. And by the way, if the things are getting tough, just like pat on your back that you are understanding something which is taught in grade 11. If you are not in grade 11 and you are still able to understand this, and which is considered to be the toughest chapter in grade 11 maths, even in grade 12, you are understanding that chapter now even in that lower grade. So it's good. Let's start. Consider a lottery where balls numbered 1 to 20 are placed in a machine, okay, and it rolls out 5 balls to produce the winning list. Okay, so 20 balls are the total number of balls and the output balls are 5. That's my R. Correct? That's my R. Okay. Now, this is a case of 20 permute 5, 20 arrange 5, 20 select 5, whatever you call it. Starting with 20 items, we make an ordered list. So the order matter. The order matter. In factorial notation, how many results are possible for 20 permute 5? You people are smart, I guess so. Can you all let me know the answer now? You know the n is 20. You know you have to fill in 5 different places. You will either do, yes, you do 20 times 19 times 18 times 17 times 16, which is actually nothing but, in short, it is always n factorial divided by n minus r factorial. Because now you understand how it comes. Very good, Mansi. This is such an easy question now. So now here is this notation which I wanted to tell you, and I told you also a little there. The number of permutations that are possible when you permute k, let's say r here, is a special symbol. The symbol is n p r. Some books may write it as n p r. It is okay. Okay, it is okay. Some of the books write like this. It is okay. It means the same thing, n p r. Okay, so P is used for permutation. It's a capital letter which is used, not a small letter, by the way. Remember this. Small letter is reserved for probability in general. So capital P is reserved for permutation here. So NPR represents the permutations of n. Total possible is how much? You start with n items and you permute r of them. You arrange how many of them? R of them. Okay. Whenever you permute r of them, it will be NPR. All the cases n will be greater than r. That has to be. And the formula that boils down is n factorial divided by n minus r whole factorial. This is what is called permutation. Permute means arrangement, selection. Okay. Let's start with the next one. Okay. Read this problem, please, and try to answer it. Lauren creates a 4-digit PIN. Okay. Which is called a personal identification number, what we know it already. And the digits are 0 to 9. We already covered this question. Deepika answered it also, I remember. Without repeating any digits in our codes. How would we express the number of different codes? Using permutation. How we will do that? Can you tell me the permutation, that notation wise? Permutation notation. Okay, let me see. 10 factorial by 6 factorial. No, Deepika, I don't want this one. This we already covered, no? Now we are doing the next theory, which is writing with P notation. I want with the P notation, permutation notation. And not the factorial one. The factorial one is done now. It's over. Now we will write using permutation notation. 9p dollar. Oh, she was typing 4. Yeah, got it. I was just looking at my keyboard. Where is dollar? Okay. So 9p4. Yes. Or you can write it as 10p4. Okay. This, yeah. So correct. There are 10 digits, Mansi. So 10p4. Very good. This is the correct answer. Okay, now you both of you know this. That's a very good point. This is how we can leave the answer, and obviously we can use the same expanded one which Deepika already written it. So let's do the next one. Okay, so a lottery becomes harder to win as the number of possible winning numbers in the lottery increases. Okay, there is a lottery where a lottery ball machine with 20 balls is used to produce a list of winning numbers. Again the same, that's the same ball, same machine, 5 balls. Which would make the lottery harder to win? Listen carefully. It becomes harder when there are more possible combinations. Okay. If I add one more ball to the machine, So instead of 20 balls putting 5 out, if I add one more ball, is still putting 5 out. Will make it a little bit tougher? I wanted you to understand this on your own. I wish you would have understood it. Or having the machine put out. So I keep the number of balls same, but I make it put or out 6 of the ball. So put out how many balls? 6. Which do you think is bigger? So now this is a very good question. 21p5 or 20p6? First one. Oh, Mansi, which one? Oh, you got it. First one, okay. 21p5 or 20p6? Which one is bigger? This is going to be tough. This is literally going to be tough. So let's write this will be 21 factorial by 16 factorial. Now you know it is this minus this we write. This will be 20 factorial by 14 factorial. So Mansi has come up with the answer 21. I'm still waiting. Deepika tells me something. Till then I'm expanding this one. So 19, 18 and 17. In this case it will be 20 times 19, 18, 17, 16, 15. So why is it I'm getting the other one? So see, 20, 19, 18, 17 is this one. Have I done wrong? Have I done wrong? Because for me, I guess this is giving me 16 times 15 and this is giving me 21. Why is it so? Your first one is different, my first one is different. Can you please, okay, let me know if I have done a mistake somewhere. 15 times 16 is what? 15 times 15 is 225. 225 plus 15 is how much? 240. And this is 21 times it. So this is 21x and this is 240x. I don't know. I thought 20p6 will be much helpful. Oh, you included 16 in first one. Oh, you included 16 in first one, but the 16 should go away, correct? I hope it is clear now. Okay. So 240x is more than 21x, and for sure this one is putting out more quotes or whatever, harder to predict. Okay. Okay, now it is okay, then we can move to the next one. Okay, I already did this, so I don't need to expand it again. You people understood this, and let's do the next one. Okay, can you all solve this now? How many tickets can be printed if 11 if 11 balls are used to create a number list made up of 11 balls? Let me see what will be the answer now. How many tickets can be printed if 11 balls are used to create a number list made up of 11 balls, all 11 balls? So basically you are doing 11p11. What is 11p11? Do you all remember that? Deepika says 11. Is 11p11 11? I don't remember. I remember NPR is n factorial upon n minus, oh Dhwani has come, okay, n factorial by n minus r factorial. Correct? So if I do 11p11, this will be 11 factorial by 11 minus 11 factorial. Now we know that it is 11 factorial by 0 factorial. So 11 factorial by 0 factorial, 0 factorial is 1. So basically it is 11 factorial. correct? Hey Dhwani, you need to look back the whole session because it's now 1 hour. So this is 11 factorial, correct? And now you have to understand why you people missed. This is where the trouble starts. When you understand less, no, you don't confuse. When you read more, no, you start to confuse. The reason is, if it is saying you there you have 11 pieces or 11 balls and you're filling 11 places. Now 11 balls, the first place can be filled by any of the 11 balls. The second place can be filled by the next 10 balls. The next by 9, then by 8, then by 7, then by 6, and so on till how much? Up to 1, no? So this is what? 11 factorial. Do you get it now? That if I do a 11, if I do a arrangement of all 11 things, if I do the arrangement of all the things, it is always the same factorial. This is what you should have started with, correct? Even though you don't know permutation, you still know this arrangement of 11 things in 11 places. They will always be 11 factorial because the things can't repeat. You have fixed number of it. Quickly say yes, because I'm repeating the same stuff, because I'm thinking you people have missed it, which is not I wanted. Have you all got it? Oh, finally, thanks. So now you people should not make this kind of error, okay? Next time, let's take up the next one. I will wait. I'll give you a time and I want you to understand and answer this question perfectly. This is just one single line answer. You people must have now remembered this thing perfectly. Yes, yes. If I do a npn, it is always a n factorial. So if I do a 10p10, it will be always 10 factorial. And if I do a 9p9, it will be a 9 factorial. So it is saying how many more lottery numbers? Correct. So 10 factorial minus 9 factorial. I know that 10 factorial is 10 times 9 factorial minus 9 factorial. So if I take a 9 factorial common, it will be 10 minus 9. So it will be a 9 times 9 factorial. What answer came up? What answer came up? So you know that you have got 10 balls, correct? And you have to produce a sequence of 10 balls. So this will be same like you are taking all the balls. You are not stopping and like keeping any ball for vacant. So 10 factorial will be the answer or the arrangement of 10 balls, correct? Now in case of 9, when you are producing 9, so it will be a 9 factorial thing. Now you are saying how many more? How many more? So 10 factorial is the total for 10 case, and in for the 9 case it is 9 factorial. So when you are subtracting it, you are taking this using the same process we understood already, and you are getting this answer. Is it clear now? I don't know why you people are missing just now. Is it clear now? You can't simplify this further, okay? You can't simplify this further. This is the limitation of this. You can multiply 9 factorial, but that's not required. Okay. This is a very, very important and the most confusing part. So now be attentive more, okay? We have to prove that is it true or not. Let's begin with the basic definition. We know that npn is nothing but n factorial by n minus r, where r is again n. So we are permuting n things out of n things. Superb. So we are permuting n things out of n things. So we actually are permuting everything. So in this case, we will get a n factorial. I hope you understand what it means. The first place can be filled in n ways, the other place can be filled in n minus 1 ways, and so on till 1. And this is nothing but n factorial. Okay. Now when you are doing a permutation of n minus 1, then you will write n factorial by n minus bracket of n minus 1 bracket factorial. Why? Because you are permuting one lesser thing than the last one. Correct. Now you will get n factorial by n minus n plus 1 factorial. Now if this has to be simplified further, it will be n factorial by 1 factorial, which is nothing but n factorial. Correct. Now you see the both are n factorial. Do you remember when I told you that if you are doing a permutation of 4 things in 4 places, you get the answer as 4 factorial? And even if you do the 4 things permuted in 3 places, then again you will get the answer as 4 factorial, because multiplying by 1 will not change anything. Correct? Multiplying by 1 doesn't change anything. So in that case, I told you adding one place has no advantage. Remember, I was talking to you in the very beginning of the class that adding one place has no advantage in case of when the repetition is not allowed. There is no advantage of adding one more extra place. That's just waste in terms of number of codes. So this is why npn and a value less than 1. So if you are arranging in 3 places, then again the same thing. I hope you understand what is n permute n minus 1 means. Okay, I hope it is clear and very well understood. Oh, this marks the completion of it also. We have finished permutation. So good, 1 hour class, superb. We have finished permutation. In the next class, we will take up combination and we will understand the difference between permutation and combination, the most confusing. I have a request to you. If possible, try to find more questions, or if you are already aware, join us here. I'm adding the text channel here. Let us add it to be the permutation class. Okay, let us create one channel here. And now all of you who are not on Discord, they can come and join on Discord. I will post some questions on permutation combination here, basically permutation from tomorrow, Monday onwards. And you will see them in either daily challenges or here you can discuss the solution. So okay, so you can find all the question here and we can start practicing something here, so that the next week when we take up permutation combination, we are very much comfortable with factorial and permutation. Okay, that's cool. And yeah, don't forget, there is one superhero being there, Xmath. We call them Xmath. Very powerful. Yeah. Okay. So any other doubt you have, you obviously can ask me in the chat box and in the Discord for, of course. Take care. Okay. Bye everyone. Bye bye.